Welcome to this lesson. We're going to continue with the Butere Girls High School examination, and I hope you're going to gain something. We have already done the section 1 of this paper. So if you've not visited our channel, please go to Shifting Grades Online School on YouTube. Remember, even though you don't attend our live broadcast lessons, after the presentation, the questions will always be available in the same channel through the same link. So we have already discussed all this. Yeah, get to the channel and equip yourself with the questions. This time around, we'll be doing the section 2 of this paper, and I hope you shall benefit. Remember to subscribe. Remember to share so that you may invite a friend to our broadcast. Number 17, which is the first question in this section. A bus left Nairobi at 8 a.m. and traveled towards Mombasa at an average speed of 80 kilometers per hour. Then at 8:30 a.m., a car left Mombasa towards Nairobi at an average speed of 120 kilometers per hour. Given that the distance between Nairobi and Mombasa is 500 kilometers, determine part 1, the time the car arrived in Nairobi. You know, this is a normal distance, speed, and time question, whereby we know that distance, speed is given by distance out of time, meaning that distance equals to speed times time, and time equals to distance over speed. So you should know the correlation between the three quantities that way. So when a car starts the journey at 8 and it's using a speed of 120, then the distance is 500. We should be able to divide 500 kilometers with a speed of 120 for us to get the time taken. So time equals to distance over speed. 500 divided by 120. This is going to give us 4 and 1 over 6. So 4 hours and 1 over 6, which means 4 hours. And we take 1 over 6 of an hour times 60. And this becomes 10 minutes. So 1 hour, 10 minutes. Now, from 8:30, we are adding 4 hours, 10 minutes. And this is giving us 12:40 hours. This is the time of the day when the car arrived at Nairobi. This can also be expressed as 12:40 p.m. in the 12-hour clock system. So any of these expressions will be correct. So that's how we get the time the car arrived in Nairobi. Remember to comment. Let us know where you're watching us from. Let's know whether you're learning something from a shifting grade. This is a relative speed, a subtopic on linear motion from 2 mathematics. The time the two vehicles met. So when are the two vehicles going to meet? Remember, there is a distance of 500 between the two. Let me sketch the information. We told that there is a total distance of 500 kilometers from Nairobi to Mombasa. Then at 8, exactly at 8, a bus is starting a journey. Then 8:30, the car is starting, meaning that before the car began its journey, the bus had already covered some distance from Nairobi towards Mombasa. So we can get that distance covered. We can get distance covered, which will be distance is given by speed times time. At a speed of 80 multiplied by half an hour, you get 40 kilometers. So there's a distance of 40 kilometers, which has been covered by the bus. So the bus is at this point, and we are at 8:30. So at 8:30, the bus has already traveled for half an hour because it started its journey exactly at 8. So at 8:30, when the car wants to start, the bus has already covered 40 kilometers from Nairobi towards Mombasa, which means the distance now in between the two towns is going to be 460. So now we are having 460 kilometers from Mombasa to the point where the bus is by the time the car is starting. So the car is also at Mombasa, and this is at 8:30. So at 8:30, the distance between the two vehicles is 460. So for the two vehicles to meet, they have to jointly cover this distance of 460. That means we start by expressing relative distance as 460, distance between any two vehicles at the same time. It's called the relative distance, 460 at 8:30. Then the relative speed shall be the sum. They will cover the distance jointly because they are approaching one another. So at a speed of 80 and the other one at a speed of 120, so 80 plus 120, this gives us 200 kilometers per hour. So they are jointly covering the distance at a speed of 200 kilometers per hour, meaning that we can get the relative time, the time taken to cover the relative distance. It will be the distance out of the speed. Let me write it well. Distance over speed. So we are talking about 460 divided by 200. This will give us 2.3 hours. 2.3 hours. And this is going to be 2 hours. And you know, the 0.3 can be multiplied by 60 for us to convert the hours into minutes. And that becomes 18 minutes. 2 hours, 18 minutes. So what exactly is this time of the day? If they will take 2 hours and 18 minutes to meet, and it's from 8:30, then they will be meeting at 10:48 a.m. the same day. This can also be called 10:18 hours in the 24-hour clock system. So that is the time they are going to meet. Now look at Roman 3. The distance from Nairobi to the meeting point. We can consider the vehicle which is moving from Nairobi. Distance from Nairobi to the meeting point. So the vehicle which is moving from Nairobi is the bus. The bus is having a speed of 80 and it will move for 2.3 hours for them to meet. So the distance it will cover, distance covered by this bus will be time times speed. So 2.3 multiplied by speed of 80, giving us 184 kilometers. So the distance of 184 kilometers is from 8:30 until they met. But you're supposed to know that it had covered 40 earlier. 40 kilometers area had been covered. Meaning that the total distance from Nairobi now, it shall be 184 plus the 40 covered earlier. This will give us 224 kilometers. Alternatively, we can still consider the car which is moving from Mombasa. So the car, considering the car, this is alternative. When we consider the car, it shall move for 2.3 hours to meet the bus, and it's doing this at a speed of 120. So 120 times 2.3, giving us 276 km, but it's from Mombasa. So the distance to this meeting point from Nairobi will be given by the total distance of 500, and we subtract the vehicle from Mombasa has covered 276. So how far are they from Nairobi to the meeting point? And when you subtract this, you get 224 kilometers. So you may consider any of the vehicles. You will still be awarded your marks. So that's how we play along in such a question. Let's look at Roman 4. How far the bus is from Mombasa when the car arrives in Nairobi. We said in Roman 1 that the car arrives at 12:40. At 12:40, the car is arriving. So how far The bus is from Mombasa. You know, the bus is the one going to Mombasa. So how far is it from Mombasa? We can check the distance it will have traveled. So all the way from 8, that is the time the bus started moving, up to the time the car will arrive, which is 12:40. How many hours will the bus have moved? So 12:40 from 8. So up to the time the car arrives, the bus has been in motion for 4 hours, 40 minutes. Yeah, 4 hours, 40 minutes. The bus has been moving. So how far has it traveled? How far has it traveled? You know, 40 minutes can be written as 40 over 60. So that we get the hours there, which is 2/3 hours. So it's this 4 and 2/3 hours that way. So for this time, the bus has been in motion. Now, the bus is having a distance which can be calculated by its speed, 80, times the time it has been traveling. And we'll get the distance it has covered. Though it is from Mombasa, it's from Nairobi. 80 multiplied by 4 and 2/3. This is going to give us exactly 373 and 1/3 kilometers. Therefore, for 4 hours and 40 minutes, the bus has covered 373 and 1/3 kilometers from Nairobi. So how far is it from Mombasa? How far is the bus from Mombasa? So from Mombasa, we need to take 500 and we subtract 373 and 1/3. So 500 minus what you're having there should be 126 and 2/3 kilometers. This is from Mombasa. So this is where the bus is. That's how you're supposed to answer such a question. So that is good. We are already somewhere. We are learning something. So thank you so much for the cooperation. Looking at number 18, we have a question here from statistics. The scores of 60 students in mathematics quiz marked out of 40 were as recorded. Between 0 and 4, we have Y students there. Then we have the other classes there. The marks have been given. So for us to get the value of Y, which is our first question, we need to take, because Y will be given by the total students are 60 minus the ones provided, 20, 18, 4, and 15. The sum of the number of students is supposed to give us 60. So that means the remaining here should be the difference of total students, because it has already been given in the statement here. And this gives us, this is going to give us the value of YS. We take 60 and we subtract 20 plus 18 plus 4 plus 15. That gives us exactly 3. So we are having 3 students here that way. So when we add all of them, we will be getting 60 students. Such a thing. Now, in the next question, we've been taught to estimate the mean score. For us to get mean, we're supposed to know that mean, when data is grouped, mean of X is given by summation of F of X out of summation of F. This is total frequency. Summation of F is total frequency. Then F of X means frequency multiplied by each midpoint. In this case, X is the midpoint. So the midpoint represents the number of students. For us to get the midpoint, we usually get the sum of the limits over 2. For example, 0 plus 4 divided by 2. So we get X, the midpoint there, is going to be 2. We again take 4 plus 12, giving us 16 over 2, 8. Again, we go to 12 plus 24, This gives us 36 over 2, giving us 18. Then we go to the next. The next is going to be 24 and 28, 52 over 2, 26. Then the next shall be 28 and 40. Then over 2, we get 34. So we have the midpoints of all the classes. We have the midpoint x of all the classes. And now that we are already having the values of f here, this is the frequency, we can get fx. Let's get fx, whereby we multiply now each frequency and the midpoint. So 2 by 3, this one gives us 6. Then 8 by 20, 160. That's 8 by 20. Then the next is 18 by 18, giving us 324. Then 26 by 4, giving us 104. Then 34 by 15, giving us 510. So most of the students are in that class. They have contributed a lot of marks because they are 15 and the midpoint is 34. So we are now having all the f of x. What we don't have is the summation of f of x. So for us to get mean of x, we need summation of everything here. 6, 160, 324, 104, plus 510, out of summation of all the frequencies. How many students do we have here? 60 of them. Yeah, 60, because it has already been provided. So I'm taking 6 plus 160, then I add 324, then I add 104, then I add 510. This gives us 1104 over 60. So 1104 over 60 equals to 18.4. 18.4. Yeah, that is the mean mark. Estimate the mean score. So the language of estimate here is to help you to know that when data is grouped, we are just estimating these statistical measures. Estimating because, for example, for the students who have scored between 0 and 4, they are 3. We don't know their exact mark, but we have taken the midpoint of that class to represent their score. So we are assuming that the 3 of them scored 2. Again, when you go to the next class, between 4 and 12, there are 20 students. We don't know where they are exactly lying, but we have taken the midpoint of the class between 4 and 12. Remember, the midpoint is 8. So we are assuming that all of them have scored 8. Then we multiply by 20 of them for us to know the marks in that class. So we're supposed to know that exactly we are doing an estimation. Okay. Now we go to the part B of this. On the grid below, draw a histogram to represent the above information. For us to draw histogram, we're supposed to know 2 things. When class intervals or class wings, when class wings are the same or simply uniform, we plot frequency against boundaries. Against boundaries. Then, when class intervals vary, like the case above, when class intervals vary, we plot frequency density against class boundaries. Against class boundaries. Now, again, according to the above type of data, which is continuous, you see from 0 to 4, then again from 4 to 12, then again from 12 to, so you see the upper limit in this becomes the lower in the second. Such a data is called continuous data. So when the data is continuous, when the data is continuous, the limits or the class limits, let me introduce that word. The class limits are also the class boundaries. So in the first class, we have limits of 0 and 4, and also the boundaries are 0 and 4. In the second class, the limits are 4 and 12, and the boundaries are also 4 and 12. As opposed to a class which could have been, let's say, 1 to 9, then 10 to 19, then 20 to 29, such a class. You see, we have a limit of 1 and 9, but the boundaries will be 0.5 all the way to 9.5. Here, we start from 9.5 all the way to 19.5, that way. So these ones are boundaries, but 10 to 19 are limits. So you find when the data is not continuous, rather when the data is discrete, it's called discrete data. We call it discrete data. So when the data is discrete, we say that the limits are different from the boundaries. But for our case, what we are having as limits will also act as the boundaries. So they are the boundaries to be plotted. So allow me now access a graphical grid where we are going to plot frequency densities against the class boundaries. Again, you're supposed to know that frequency density is usually given by frequency out of class width. Each frequency over the class width. Therefore, we can get now a column of frequency densities and frequency density for the above data. We need the frequency densities and also the boundaries to be plotted. So we get frequency density here. The class will come here. So we have from 0 to 4, then from 4 to 12, then from 12 to, you can check, from 12 to 24, then to 28. 24 to 28, then from 28 all the way to 40. 28 all the way to 40. So the classes are that way. Yeah, 1, 2, 3, 4, 5. 5 classes. 1, 2, 3, 4, 5. 5 classes that way. So each frequency over the class width. Frequency over class width. The first frequency is 3. Now 3 will be divided by the class width is 4 minus 0, which is just 4. So I'm getting 0.75 frequency density. The next class, 12 and 4, are giving us a class interval of 8. So the frequency is 20. So 20 over 8, giving us 2.5. From 24 to 12, we will have a class interval of 12. What is the frequency? The frequency is 18. So 18 over 12, we get 1.5. The next, from 28 to 12, from 28 to 24, sorry, we have a class width of 4. So the class width of 4 should divide a frequency which is equal to 4. 4 over 4. We are getting 1. Getting 1. Then from 40 to 28, we have a class interval of 12. So the frequency there is 15. So 15 over 12. 15 over 12. This gives us exactly 1.25. 1.25 that way. 1.25. Now, with the frequency densities and the classes are already here, we can now plot on this graphical grid. Allow me draw my axis here now. That's where frequency density shall be for these classes. Then on the horizontal axis, we are talking about the class intervals. You know, we are starting from 0 all the way to 40. 0 all the way to 40. So we will have a class boundaries here, or simply the max will be here. So from 0, we can go to 5, 10, 15, 20, 25, 30, 35, then 40. And we can even check on the scale. We can even work with a different scale. Yeah, but this one is convenient. Let's get a suitable scale for the frequency densities. Frequency densities are running from the highest one is 2.5 and the least one is 0.75. So we can use intervals of 0.5. We can use intervals of 0.5. So with 0.5 here, we will have 1.0 here, then 1.5 that way. We go to 2.0, then we will have 2.5 there. That way, we can also talk about 3.0. Yeah, that's now the scale for the frequency densities. Now, in the first class, we are having 0 to 4. Okay. I think we need a better scale for these classes now. 0 to 4. 0 to 4. Yeah, we can even use it that way. 0 to 4, then from 4 to 12. So 0 to 4, we will have a height of 0.75. So 0.75, 0.75, this 0.5, 0.6, 0.7. So 0.75 is here. 0.75 is exactly there. So 0.75, that will be the height. Let me use a different color now for the bars. And 4 is here. This is where 4 is. See, now with this kind of a scale, we are in a position to read even the second decimal place. That is the first bar. The second class is starting from 4 all the way to 12. So from 4 to 12, and the height is 2.5. 4 to 12, 12 will be here. That way. That's where 12 is. And we can see where 2.5 is. So the secret here is coming up with a very good choice of scale, which will accommodate your classes and also the frequency densities. The frequency density that way. Then the next class is having a height of 1.5 and it's going all the way to 24. So all the way to where 24 is. 24 is just before 25. Just before 25 that way. Then we're talking about 1.5 as the height. Now the height is the frequency density now. Then after that, we will talk about from 24 to 28, and the height is 1. 24, 28, and the height is 1. 28 is just somewhere here. Yeah, and the height is 1. 1 unit that way. Then finally, from 28 all the way to 40 with 1.25 as the answer. All the way to 40 with 1.25. So 1.0, 1.2, the 1.1, 1.2, 1.25, because you have 1.3 up there. So 1.25 is at this point. Yeah, that point. Now we are having our histogram. We got our histogram that way. We have our histogram. So this is the histogram that the examiners intended. This is what the examiners wanted to see. A very good histogram. Should be in a position to do a good scale for you to get a good graph. That way. That way. That way. Okay. After this, we are taught to use this histogram to estimate the median, to determine the median. So before we get the median, we're supposed to get the median class. So we are going back to our data and we come up with what we call, I'm just rubbing this one for convenience so that I may get what we call cumulative frequencies, CF. So we start with 3. 3 plus 20, we get 23. 23 plus 18, we shall get 41. 41 plus 4, I'm getting 45. Then 45 plus 15, I'm getting 60 total frequencies. So 60, for us to get the median class, we are supposed to get 60 divided by 2. This gives us 30. So we need the class where the 30th student is contained, and that is the class 12 to 24. 12 to 24, that way. Something else that we're supposed to know is that, okay, we have known the median class, 12 to 24. That's the median class. Class 12 to 24. The median value lies there, 12 to 24. Now with this class, we know that the median is a value anywhere there. So we're supposed to know again, because frequency density, which is our height, is given by frequency out of width. Then for us to get the frequency back, we're supposed to multiply frequency density times the class width. Frequency density times the class width, which means frequency density times class width is giving us frequency, and this is the area. Frequency is given by area now of each bar. Area of each bar in the histogram, which means we can know the number of students lying in each class. Then we want to identify the area that will give us the 30th student. The area that will give us the 30th student. So in the first class, when we multiply the height, which is 0.75, by the width of 4, we are getting the 3 students. So in the first class, we are having our 3 students. 3 students. Then in the second class, 2.5 and a width of, this from 4 to 12. So a width of 8. We are getting 20 students, and I hope that is the right value. We are getting 20 students. So there are 20 students in this class, which means now for us to get the area that will give us, to get the first area giving us 30 students, we need now more 10. We need more 10 units now. Along this axis, we need area that will give us 10. And we are having a fixed height of 1.5 in this class. This is now the median class. This one is the median class. The class containing the 30th student. So what mark will correspond to the 30th student? For us to know that, we have to know that we're already having 3, then 20, that is 23. So for us to get 30 students, we need 7 more. So 7 students is the frequency we need. So this needs the height, frequency density of 1.5 in this class, multiplied by a width here, which is not known. A class width that we don't know here. So this class width will be given by 7 divided by 1.5, giving us 4.667. 4.667. That way, 6 is recurring. 4.667. Therefore, with the fixed height of 1.5, then at the width here, because we have that height, at the width, we only need a width of 4.66, which will give us 7 students. And that width, when we are moving from 12, we just add 4.667. This will give us 16.667. This is the median now. So we can draw a vertical line to show that median. So from 12, when we add 4.667, we're going to have it at, we add 1, 2, 3, 4, then point something now at the middle of that small square. So we raise a line there. That way, so leave the median line. The value is estimated as 16.667. That way. So you find now with the width that we have added of 4.667, we multiply by the height of 1.5 and we will get 7 students there. So with those 7 students there, when we add to the first 2 classes, 20 and 3, we will get 30. So the median mark is 16.667. So from the graph, we are estimating 16.667. That is the median value that way. And actually, we can compare this value. We can compare this value with a median that is gotten from the formula. We are already having the median mark, the median class. So median is given by lower boundary plus n/2 minus cumulative frequency just before this class out of frequency of the class. Then we're supposed to multiply by the class width that way. So we are having the lower boundary is 12 plus n/2 is 30. 60/2 is 30 minus cumulative frequency just before this class. Cumulative frequency just before this class, 23. Just before the class, we are having a cumulative frequency of 23. Divided by frequency of this particular class now. Frequency of this class is 18. Frequency of the class is 18. Then we multiply by the class width. From 12 all the way to 24, we have a class width of 12. So this will give us the median from the formula. 12 plus, when we take 30, we subtract 23, we multiply by 12, we divide by 18. This will give us 4.667, and we'll get the same as what we got from the graph. So the two estimations are the same. Let's get to number 19 now. In number 19, we are talking about an investment group that decided to raise 800 Kenya shillings towards a charity fund. They agreed to contribute an equal amount of money. Before they paid, 4 of them pulled out. And those that remained were supposed to pay an additional 10 Kenya shillings. In part A, you know, these are quadratic word problem. Even when you have started reading, you can see where it is taking us. Those who have experienced the book 3 work, this is topic 1. And from the language used here, you can relate and know what the examiner is about to tell us to calculate. Therefore, now we are told that if the initial number of members was X, write down an expression of what each was to contribute originally. So each was supposed to give, you know, they were to give a total of 800 and they are X. So each was to give this Kenya shillings. Then another expression of what each of the remaining members contributed. They are supposed to meet the target of 800. And now we are told that 4 of them pulled out. So they became X minus 4. So we divide the amount to be contributed by the number of contributors. The number of contributors. Initially, they are X. But now finally, they are becoming X minus 4. So that is the expression that the examiner wanted. And you get a mark for each that way. Now, let's go to the real question now. Calculate the number of members who were initially in the group using the expression in A above. So we are supposed to tell ourselves that, you know, when somebody has gone, they are now contributing more. So the amount they are giving now is more. The amount they are giving finally minus the amount they were to give originally is equal to 10. The difference between the two amounts, what they were supposed to give and what they are giving now is 10. So they were supposed to pay an additional 10 for them to meet the target of 800. So when we take what they are giving now minus what they were to give initially, we should get the difference of 10 shillings. Then now we solve it now as an equation. Remember, 10 is automatically over 1. So X minus 4 into X, that is the LCM. When I divide the LCM by the first denominator, X minus 4 will cancel. So I'll be having 800 into X, then minus 800 into, when I divide the LCM and the second denominator, I will have X cancelling. So that I remain with X minus 4 at that point. This is equal to 10 multiplied by, when I take the LCM and I divide by 1, it will remain the way it is, then times 4. That will be X squared minus 4X. I've expanded the LCM now at that point. Now we can drop the LCM and we simplify. 800X minus 800X, then positive 3200. Negative 800 by negative 4. It becomes positive, equals to 10x squared minus 40x. Let's work with the grouping of terms now. So at this point, 800x minus 800, that goes. So we can start with 10x squared minus 40x. Then that 200 can be taken to the same side. then we shall remain with a 0 on that side. This equation can be solved either this way or it can be made simpler because I can see a common factor here. When we divide through by 10, this shall be x squared minus 4x minus 320 equals to 0. That way. Yeah, equals to 0. Then now with this, we can solve now the equation quadratically using any of the methods of solving quadratic equations. We can use the factorization. We can also use the completing square method, and we can also use the quadratic formula itself. Allow me prefer the completing square method. The completing square method. So x squared minus 4x. Then I take 320 to the right, such that I need to add a constant and also bring the constant to the other side. This constant is meant to ensure that the left-hand side becomes a perfect square. And how do we get a perfect square? A perfect square expression is such that if the coefficient of x squared is 1, then b is usually equal to the constant. Okay, the constant is usually provided by, the constant c is usually given by b out of 2 squared. So b is negative 4 over 2. Then we square. Negative 2 squared becomes 4. 4 and 4 that way. So with this, as we add to get 324, on the right-hand side, we are getting 324. So on the left, we can factorize. To factorize a perfect square, we take the square root of the first term, the sign that follows, which is a minus, the square root of the constant, which becomes 2 squared. So x minus 2 squared equals to 324. From this point now, we are supposed to get square root of both sides of this expression. When you take square root, x minus 2 squared becomes x minus 2. This is equals to the square root of 324, which is either plus or minus 18. Plus or minus 18, that way. So how do we remain with x? By taking positive 18 plus 2, which is 20, or x equals to negative 18 plus 2, which is negative 16. And now that we are dealing with number of people, then x, which is positive, will dominate in this case. So we are having 20 people originally. 20 people originally. 20 people originally. What were we finding? The number of members who were initially in the group. And we gave it x. So the value of x is 20. That way. That way. Remember to subscribe, guys. Remember to share, to invite a friend. Yeah, this is your home. Shifting Grades is your home for academics. Let's look at part C. The amount each contributed after the 4 withdrew. So they have to raise not 1800, they have to raise 800. And how many are they now? 4 have withdrawn. So 800 divided by 16 members. Each is going to contribute 50 bob. 50 exactly. So every person is going to give us to contribute 50 for them to meet their target of 800 because they are now 16. Somebody or some people withdrew from the organization. They said they cannot give even if it is for a charity fund. Okay, number 20. Number 20 is a question from intersecting circles. Area of part of a circle. This is from 2 work. It's good for you to know that from 2 work is very critical, even to from force. So it's good to remain around until we cover everything. Yeah, we are also requesting for your facilitations in our programs. So if you are able, kindly use the till number attached on the wall. That is a 49777742 to support our programs. Any amount will go a long way. So just send what you have and our programs will be brought to you conveniently. So thank you so much for the continued support. Back to the paper now, number 20. Two intersecting circles have centers P and Q as shown below. The circle, center P, has a radius of 8 centimeters. Then the circle that has center Q, radius is 9 centimeters that way. Then again, we are given further instructions that the distance between the centers P and Q is 14. So from P to Q, we have a distance of 14. And we are also given that the ratio of P to B, we can see point B where it is, and B to P is 3:4. Calculate part 1, the angles, the angle APC and also the angle AQC. Okay, let's first deal with this ratio of lengths. You know, this is a total length, whereby we are having 3 proportions and 4 proportions, yet the total length is 14 centimeters. So from P to B, we have 3 proportions out of the total 7 multiplied by the length. So we are getting 6 centimeters. Then from B to P, B to Q, sorry, B to the other end now, which is Q, we talk about 4 proportions over 7 multiplied by 14. This is going to give us 8 centimeters. So that is how the 14 centimeters has been split. 4 proportions and 3 proportions, giving us 6 centimeters, 8 centimeters, respectively. So now, let me now redraw the diagram here, such that everything becomes more clear. So we are talking of 6 centimeters here and 8 centimeters. Then on the other side, we are talking about 8 centimeters and 9 centimeters that way. So these are the diagrams that we are having. This point A, this point P, this point Q. So let's get the angles that we are requested to find. The angle APC. APC means the whole of this angle. The whole of this. So you get the alpha first. Let me get angle alpha. The angle APQ first. And I'm going to apply trigonometric ratios because the triangle is right-angled. So with the hypotenuse of 8 and the adjacent length to this angle of 6, we can apply cosine of an angle. So the cosine of alpha will be given by adjacent length of hypotenuse, meaning that alpha will be given by the cos inverse of 6/8. So cos inverse means shift cos 6/8. This gives us exactly 41.41 degrees. If that is the angle, then we can get the angle now, ABC, which is the whole angle, 41.41 multiplied by 2. When we multiply this by 2, we shall get 82.82 degrees. So we need to multiply now to get the whole angle now. APC. So we got alpha first. Then on the other side, allow me call the angle here angle theta. So we are supposed to get theta first. Then for us to get AQC, we have to multiply theta by 2. Again, we apply cosine. So the cosine of theta is given by, according to theta, the adjacent length is 8, then over the hypotenuse, which is 9. Meaning that theta will be given by the cos inverse 8 over 9. So you go again to shift cos 8 out of 9. You know, this gives us 27.27. So 27.27 degrees. So that the whole angle of AUC now becomes, when we multiply this by 2, we're getting 54. Is it 54? Should confirm that. 27.27 multiplied by 2. 54.54 degrees. So we have gotten the angles by applying trigonometric ratios, or simply trigonometry. Okay. Now, in part 2, in part 3 of this, we are finding the area of the shaded region, and the answer will be left to 2 dp, or rather 2 decimal places. Let's look at that. Let's look at that. I'm supposed to look at the shaded region. You can see now we will talk about segments now. Segments. These shaded regions can be divided. First, we are having a region 1 and region 2. 2 segments that way. So the first segment is in a sector AQC. Sector AQC. So we have to get area 1, area 2, then we add. So using the sector AQC, yeah, that's AQC. We need area 1, which is here. So we need area of the sector minus area of the triangle for us to get the minor segment. So area of a minor segment is usually given by area of a sector, the whole sector AQC, minus the triangle inside this sector. So this is the triangle. So we should get the whole sector minus the triangle. So we need beta over 360 pi r squared, sorry. Beta over 360 pi r squared minus half AB sine beta for us to get the first shaded area, the first minor segment. So beta at Q, the beta is 54.54. Divided by 360 multiplied by pi. Radius for that case is 9, yeah. Squared that way. Then minus half, 2 sides, AB, sine of the angle between them, 4.54. So this is going to be 54.54 multiplied by 2 multiplied by 9 and 9. Then we divide all this by 360 by 7. This will give us 38.57 minus half multiplied by 9 multiplied by 9, then the sine of 54.54. This will give us 32.99. So the area of the first minor segment is going to be 38.57 minus 32.99, giving us exactly 5.58 square centimeters. That one is done. The next is the other minor segment, whereby we will talk of now a different sector, that is AP what? Let's look at it. Yeah, APC, the other sector. APC, then it's having a triangle in it. APC, and it's having pattern triangle in it. Is our second minor segment, which means for us to get the minor segment, we again need area of the sector minus area of the triangle in it. So area of the sector is beta over 360. So we can see the radius there is 8, and the data we got is 82.82. So 82.82 over 360 pi r squared, then minus half 2 sides sine of the angle between them. Yeah, sine of the angle between them, that way. So what are these values? Can compute them very quickly. 8.82. This one multiplied by 2 point. Okay, multiplied again by 8 by 8. Then we divide everything by 360 by 7. This gives us 46.27. Minus half multiplied by 8 times 8, the sine of 82.82. This gives us exactly 31.75. So this shall be, we take 46.27 minus 31.75. This is going to be 14.52 square centimeters. Therefore, we have gotten the first minor. You know, now the combination of this sector and this other sector is what gives us the unshaded area in this case. The unshaded area. Okay. So we have area of the unshaded areas, by the way. And remember, what we need is the shaded region. What we need is the shaded region. So we can talk about now the 2 triangles added to give us the whole of this area. Now consider a figure which is called a kite, actually. Figure AQCP. AQCP. The figure AQCP is 2 joint triangles, whereby total area of AQCP, total area of AQCP, the total area of that kite, the figure will be called a kite. That area will be equal to the 2 triangles added. 2 triangles added, that is 32.99. And the other triangle, which is 31.75. When we add the 2 triangles, that's 2.99 plus 31.75. This will give us 64.74 square centimeters. Then total unshaded, unshaded, which is 5.58 plus 14.52. The first unshaded area, and the second unshaded area. What will it give us? 5.58 and 14.52. This gives us 20.1 square centimeters. If we have the total area of the kite, AQCP, and now we are having area of the unshaded part, then we can get the area of the shaded part now. Shaded will be the difference. So this will be 44.64. Yeah, 44.64 square centimeters. So that is what you were intended to work. Very simple. Very simple. Very simple. Shaded region to 2 decimal places. So the shaded region is this one and this one. So that is what you're supposed to add. So I hope you have followed keenly. Let's get to number 21 now. The diagram is having a simple error here, but at least we can understand what we are being given there. So we can now read the question together. We can read the question together. In the figure below, AD is diameter of the circle, the center is O. Then given that AB and BC are equal, this length and this one are equal, then that the angle DAC, the angle DAC is 38, you can see that. And again, the angle ECA is 50, you can also see on the diagram. Giving reasons, determine the following angle. The following angles, 1, DEA. DEA. DEA is the angle at this point. DEA. Actually, DEA, the whole of this. And I will give it directly 90. Reason, angle subtended by diameter. So angle subtended by diameter to the circumference is usually 90 degrees that way. So we have 90 degrees at that point. It's good for you to know that some other times the diagram will not be giving the angle. It is you to connect a few chords to produce the angle that we are talking about. DEA, it had not been drawn, so we had to produce the length that way. ABC, the other angle is ABC. The angle at this point, let me change my color so that you may know what we are working out. The value of X there, that is the angle we want. Okay, let me start slowly. And I will start by filling these angles. You know, at this point, we can also talk another 90 there. The diameter produces the angle at C, so that's 90. And we have part of it as 50, meaning that the remaining here is 40. Now, with 90 there and 38, we can get the missing angle here. The missing angles there, using the angles in a triangle concept, we have to take 180, we subtract 90 and 38, and we get a 52. So the angle here is 52. If that angle is 52, we can follow the concept of opposite angles in a cyclic quadrilateral. What is a cyclic quadrilateral? A four-sided figure whereby all the vertices are touching the circumference of the circle. ABCD is a cyclic quadrilateral. ABCD, a cyclic quadrilateral. Therefore, opposite angles in a cyclic quadrilateral are supplementary. They add up to 180. Therefore, when we take 180 and we subtract 52, we shall get the angle at B because it's opposite to 52 according to that cyclic quadrilateral. So 180 minus 52 gives us 128. So this is 128 degrees. That means now, following triangle ABC, the remaining angles should be equal. That is called isosceles triangle. 52 should be divided by 2, so that we get 26 and 26. So 26 and 26. The value there is 26. Reason being, okay, we have applied several concepts, but what was the final concept that we have applied that led us to the answer? Properties of angles in a circle. Opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are what? Supplementary. They are supplementary. So that is the concept we have applied. Let's look at okay, A, B, C we have done. So B, D, C. B, D, C. BDC. Let me talk of another angle there. BDC. BDC. So the angle is supposed to be at this point, BDC. BDC is supposed to be this one. So I draw. So BDC means the angle at that point. BDC, that is the angle we want. So when you look at that angle, it has been produced by chord. It is chord BC, which has produced that angle. And again, chord BC has also produced another angle, 26. Therefore, angles subtended by the same chord are usually equal. So we say it is equal to 26. So the angle is supposed to be equal to ABC. Reason being, angles subtended by the same chord. Angles subtended by the same chord are supposed to be equal. They are supposed to be equal. There is another angle here that we are supposed to work out, and that is angle BOC. The angle BOC. BOC, let's look at it. The angle BOC means the angle BOC, let me project it for you. BOC is going to be the angle at this point. BOC shall be this angle. Now, looking at that angle, it has been produced at the center of the circle. And again, it has been produced by a chord, which is BC. Now, BC is producing an angle at the circumference, which is 26. And now at the center, it produces another angle. What is the relationship between those two angles? So we need to say the angle is going to be 26 by 2, giving us 52 degrees. Then we say angle at the center is twice the angle at the circumference by the same chord. The angle produced at the center is usually twice the angle at the circumference by the same chord. So the same chord BC produces an angle of 26 at the circumference, and now it produces another angle at the center. So the angle at the center should be double the one at the circumference. Then we are talking about the reflex angle. The reflex angle AOC. So we are supposed to first identify where AOC is. We identify where AOC is in the diagram. We identify where yeah, is it AOC? Yeah. AOC reflex angle. AOC, the whole of this angle now. Let me indicate it using a different ink. The whole of this AOC, the angle there. But now we need the reflex one. The reflex one. This one is the one we have indicated is obtuse. Now the reflex one is usually greater than 180. Yeah, greater than 180. So let's get first. Let's get first. Let's get first. I think that is where the exam is now, and we should work it out very keenly. Look at this. The inner angle, the obtuse one, has been produced by chord AC at the center, and chord AC is producing another angle at the circumference. Yeah, another angle at the circumference. So ours is to say that using figure EABC, which is a cyclic quadrilateral, and we already know the value of this angle at B is 128. That one we worked out early as 128. Then the opposite one should be exactly 52 because it is a cyclic quadrilateral. EABC, or we can say CEAB, that cyclic quadrilateral. 128 should be opposite with 52. Now we'll say this, that the chord AC is producing 52 at the circumference, and again producing another angle that we want at the center. The angle that we want at the center. Therefore, we say 52 times 2. 52 times 2 is a 104. So the angle, which is obtuse AOC equals to 104. Meaning that the reflex one now, the reflex AOC will be equal to, we take 360 and we subtract, because it's angles at a point now, subtract 104. So 360 minus 104, we get 256 degrees. 256 degrees. So the angle that we wanted is equal to 256 degrees. This is an angle setup point. Angles at a point, they are supposed to add up to 360, and we have applied that concept. So it's a very good question, which I believe that you guys have gotten something. Looking at number 22 now, which is our last for this session. We'll continue with the paper later, but now we can check number 22, the last one. The figure below shows a frustum of a square-based pyramid, which is not drawn to scale. Square-based, 10 by 10, you can see. The base ABCD is a square, side 10 centimeters. Then the top ABCD prime is also a square, side 4 centimeters. And each slanite is 5 centimeters. As you can see, each side is 5 centimeters. So we are having 5 centimeters here. Each side is 5 that way. That way. Yeah, so we have the diagram. Let's look at the questions now. Calculate the altitude. Calculate the altitude of the original pyramid. That means we are finding, no, attitude is the vertical height. Another name of attitude means vertical height. We are finding the vertical height. So let's see, trying to sketch the original pyramid. Trying to sketch the original pyramid. Yeah, original pyramid. That way, assuming this is point B. Now we want the height from that top all the way to the base. The height that we want will pass through AC. We want the height here. That is the height we want. So we are going to apply similarities and enlargements in this case, so that we first get what we are calling the slanting heights. So we say that a slanting height, there is a, for us to get a frustum, we need to realize that there is a small cone which was cut off here, which is also having a slanting height, small letter L. So we say the biggest slanting height of the original cone will be 5 plus L. When we divide by slanting height of the smaller cone, which was cut off, which is L, we're supposed to get, because they are both linear measurements together with the lengths here, we're supposed to get 10 out of the smaller one, which is 4. So the length of the original cone, not cone, sorry, pyramid, is 10. And the length of the smaller pyramid, which was cut away, is 4. So the smaller pyramid, which was cut, is having a length of 4. So the ratios should be the same, using the slanting heights and also using the lengths. So here we shall have cross multiplication of 10L, giving us 20 plus 4L. This means that 6L equals to 20. Yeah, 6L equals to 20. So that the length L equals to, small l will be 20 over 6. This will be 3.33. That way, 333. That is the small letter L, meaning that the capital L equals to, when we add 5 to the smaller L, which was cut, we get 8.333 that way. So now that we have now that we are having the capital L is 8.333 and the smaller L is also given. The question is original height. So for us to get original height, we can get the length here from A to X, whereby we first apply what we call Pythagoras theorem. 10 and 10, so that you get the length AC. So 10 squared plus 10 squared, the square root, so that you may get AC, Pythagoras theorem. So 10 squared plus 10 squared, then the square root, we're getting 14.14. 14.14 centimeters. That's length AC. So what about length AX? We divide AC by 2. This gives us 7.07. 7.07 centimeters. Now with 7.07 centimeters as the length AX, sorry. Now we can use AX together with the slanting height for triangle VAX. Look at triangle VAX now, whereby this is, let me indicate now the length here, 7.07. So with triangle VAX, we can use the hypotenuse and the base for us to get the height. So the height shall be 8.333 squared minus 7.07 squared, and we take the square root. So what will be this height? What will be the height? This is going to be 8.33 squared minus 7.07 squared. We take square root, and we're getting 4.41 centimeters. 4.41 centimeters. Yeah, 4.41 centimeters that way. 4.41 centimeters. Then now we get back to, yeah, now we have to get back to part B. Calculate the surface area of the frustum. Is it a solid frustum or it's open? This one is a solid frustum, so it will have the top and also the base. So surface area will be given by area of all the faces that we can see. Area of all the faces that we can see. And remember, the slanting edges are all equal because it is square-based. So they are all equal. So the base is 10 by 10, giving us 100 square centimeters. The top is 4 by 4. This is giving us exactly 16 square centimeters. Then slanting heights, which are 4 and are equal, we get their area. We get their area. Area of the slanting edges. So for the slanting edges, we need to come up with what we call the height first. So out here we will have from B to a point here, which you can call M. We need to get that length. Yeah, we need to get that length. We need to get that length, whereby we can use 8.33, and from A to M, we have 5 meters. So I'm dividing it by 2, 5 meters that way. So the height VM is going to be 8.33 squared minus 5 squared. Pythagoras theorem. 8.333 squared minus 5 also squared. Then we take the square root for us to get the height. 8.33 squared minus 5 also squared. Then the square root 6.67 centimeters. Then we are also having a smaller triangle which is being cut off. So the smaller triangle which is being cut off will have, the smaller triangle will have also a certain small height. That small height can be calculated using either Pythagoras theorem again, or yeah, we can use Pythagoras theorem again. Remember, this is the 3.33, and now we are talking about 2. Yeah, we are talking about it was already 4. The total is 4, so we use 2. We again get the small height. So 3.33 squared. 3.33 squared minus 2 squared. We take square root again. And we can also use similarities and enlargement to get the other length. So 3.33 squared minus 2 also squared. Then the square root, we are getting 2.67 centimeters. That means Now we have two options here. Two options are here for us to get the area of the shape or the slanting edges of the pyramid. Let me show you what we have. The options. The options that I'm talking about, I am supposed to display them here. We can talk about, we are having such a thing. So we have the total height over here. We have the total height, and we also have the smaller height. We have the smaller height. We have the bigger height. So we can calculate the area of a triangle, the bigger triangle, minus area of the smaller triangle. Or we subtract the two heights. When we subtract these two, we shall get 4 centimeters. And 4 centimeters will be the height between two parallel lines, this one and this one. So we can use AB and AB prime as a trapezium. Then we get area of a trapezium, one of them, times 4. So area of a trapezium here times 4, or we get area of two triangles and subtract. Then we multiply the difference by 4. Let me give you the two options. We start by choosing the triangle way. Triangle way will have half multiplied by half multiplied by 10 times a height of 6.67. What will this give us? This gives us 33.35. Then we subtract half multiplied by a base of 4 times a height of 2.67. So half multiplied by 4, which is the base, multiplied by 2.67. This gives us 5.34. So the difference now, 33.35 minus 5.34, we're getting 28.01. Now we take 28.01 and we multiply by 4 such phases. So by 4, this will give us 112.04 square centimeters. So total surface area will be, when we add the base 100, the top 16, and the slanting edges totaling to 112.04. This gives us 228.04. Square centimeters. That is the total now. Alternatively, I was talking about this. We subtract the two heights and get the height between the two parallel sides here, between this and this. So that we say this landing height, this landing area is given by half the two parallel sides, 10 and 4, multiplied by the exact height between them. So we'll be having 14 multiplied by 4 divided by 2, giving us exactly 28. And you see the other one was 28.01. So we just have a slight error due to the round-offs. Then we multiply this one by 4 of them. 28 by 4. This will give us 112. So the areas are almost the same for the curved surfaces. That is the alternative I was talking about. In part C, we are to find the volume of the frustum. For us to get the volume of the frustum, we need volume of the original minus volume of the smaller pyramid, which was cut. So we need a third multiplied by base area times height. 10 times 10, then times the vertical height. So the vertical height is 4 point. That's what we got first. 4.41. So original volume will be a third multiplied by 10 times 10, then multiplied by 4.41. This gives us 147 exactly. Then the smaller one, which was cut, we can use several methods here. We can use similarities and enlargements, or we just get the vertical height for the smaller one. That one we had not calculated, so we can just find it. The vertical height of the smaller will pass through there. Yeah, the vertical height will pass through there. Remember, when we get vertical height of the bigger, 4.41, divide by vertical height of the smaller, we should get the same as when we take the length over the other length. We use, instead of Pythagoras theorem, we use similarities and enlargements. So height will be, when we take 4 times 4.41, then we divide by 10. This gives us 1.764. 1.764. So we work out now the volume using a third multiplied by base area 4 by 4 times the vertical height there 1.764. We get volume of the one which was cut off. A third multiplied by 4 multiplied by 4. Then we multiply by 1.764. This gives us 9.408. So volume of this pyramid shall be the difference. 147 minus 9.408. This gives us 137.592 square centimeters. So that is how we work out volume and surface area for pyramids or for frustums which have been cut from a pyramid, which are square-based. Thank you so much for following. Remember to support our programs using the till number which has been attached on the board, 497772. Otherwise, thank you so much for following. Subscribe and share.